All right, let's just dive right in. I want you to put yourself in the shoes of a senior architect for a minute. You're running a pretty complex GKE environment. You've got multiple teams, tons of namespaces, services spinning up and down all the time. You've basically built a thriving digital city. But there's a huge challenge hiding just under the surface, and that's exactly what we're going to tackle today.
See, your cloud environment is a really busy place, right? Team Alpha is shipping the front end, Team Bravo is pushing updates to the checkout service, Team Charlie's managing all the data pipelines. On the surface, it's all working. But the real challenge? It's in the connections you don't see. It's all that east-west traffic, the chatter happening between all of those services. And that, right there, is the million-dollar question. It's not just about, hey, can the front end talk to the back end? It's about how it's talking to it. Is that communication encrypted? Can you actually prove the service calling your database is the one you trust, and not some imposter that's snuck onto the network? Let's be honest, right now, you probably can't.
What's so wild is this massive difference between what you see and what's really happening. On the left, you've got your Kubernetes dashboard view. It's clean, it's organized, you've got your logical namespaces, it feels like you're in control. But on the right, that's the network reality. It's basically the Wild West. Any service can talk to any other service, totally unencrypted, with zero identity verification. It is a massive security incident just waiting for an invitation.
So how do we fix this? How do we bring some law and order to this chaos? Well, this is the exact problem a service mesh, and in our case, we're talking about Istio, was born to solve. And look, this isn't just another tool you install. It's a fundamental change in how you manage, secure, and even see what your services are doing.
I really like this analogy, so let's stick with it. If your services are all the buildings in that busy city, think of Istio as the city's brand new intelligent traffic grid. It's not just laying down pavement. We're talking about building secure armored tunnels for every vehicle, putting ID checkpoints at every single intersection, and having a central traffic control tower that sees every trip from start to finish.
Okay, so let's switch from the analogy to the tech for a second. A service mesh is a dedicated infrastructure layer that gets baked right into your platform. Its whole job, its entire reason for being, is to manage how your services talk to each other. And by doing that, it gives you these three incredible superpowers: reliability, observability, and the one we're really focusing on today, rock-solid security.
And inside that security superpower, the very first tool we're going to pull out of the toolbox is Mutual TLS, or mTLS. You should think of this as the concrete foundation you're pouring for a true zero-trust security model where, by default, we trust absolutely nothing.
And this is the classic architect's dilemma, isn't it? We want to flip the big red security switch on, but our number one fear is that in doing so, we're going to break something critical. The business does not care about our security goals if the site is down. So how do you roll out such a massive change safely?
So what makes mTLS so special? Well, you already know about the regular TLS that gives you that little lock icon in your browser. That's one-way authentication. The website proves its identity to you. With mTLS, it's a two-way street. It's mutual. Service A proves who it is to Service B, and Service B proves who it is right back to Service A. Only after they both check each other's IDs do they open up that encrypted channel. Basically, no imposters get in, period.
The answer to doing this safely is right here. You don't just flip a switch and hope for the best. You start by enabling mTLS in what's called permissive mode. This is your safety net. It tells the service mesh, hey, I would prefer encrypted and authenticated traffic, but if some service isn't ready for it yet, go ahead and let the old unencrypted traffic through. This gives you breathing room to watch, to find those weird edge cases, and to fix things without causing a single bit of downtime.
Okay, enough with the theory. Let's make this really concrete. I'm going to walk you through a real-world scenario that shows you exactly why this phased approach is so incredibly important. This is a story about a team trying to do everything right, making one tiny mistake, and how the system they built saved them from a total disaster.
So the team was feeling pretty good. They had mTLS running in permissive mode, traffic was flowing, everything looked great. They were ready for the next logical step, implementing an authorization policy. This is where you move beyond just encryption and start defining which services are actually allowed to talk to each other. A fantastic security goal. And then it happened. A classic human error. A typo in a YAML file, a misconfigured selector. A developer trying to write a rule to allow specific traffic accidentally wrote one that denied all traffic to a critical namespace. A simple mistake that could have brought down a huge piece of their application. And just like that, the pager starts screaming.
The Slack channel for Team Bravo just lights up like a Christmas tree. The checkout service, probably the most important part of their e-commerce platform, is throwing errors left and right. This is that moment that every single operations team absolutely dreads.
But here's where the observability from the service mesh became the hero of the story. Instead of frantically digging through terabytes of logs, the team just pulled up their traffic dashboard and the problem was staring them right in the face. You can see it here. The checkout service wasn't down at all. It was actively rejecting requests from the front end and recommendation services with a 403 forbidden error. This told them immediately, this isn't a crash, it's a permissions issue.
And this number right here, 12, that's the most important part of this whole story. That is how many users were impacted before the team fixed the issue. Why so few? Because they were following a staged rollout. That broken policy was only applied to a tiny fraction of their production traffic. The blast radius was contained, reverting the change took a couple of minutes, and that near miss never turned into a full-blown catastrophe.
So that story isn't just a scary tale to tell around the campfire. It is the foundation for a proven, repeatable strategy. We're going to take the lessons from that near miss and forge them into a blueprint that you can use to harden your own environment, moving step by step from permissive all the way to strict enforcement.
This is what you, as the architect, can now take to your leadership, to your security team, to your fellow engineers. It's a plan that proves you can get a really powerful security posture without putting the stability of the business at risk. It shows that security and stability can and should go hand in hand.
And here is that roadmap. Phase 1, weeks 1 and 2. You just deploy Istio and turn on permissive mTLS. Your only job is to watch and learn. Phase 2, weeks 3 and 4. Now you start writing and testing those stricter authorization policies, but you do it in staging where it's safe. Then comes Phase 3, week 5. This is a critical step from our story. A canary release of your new policy to just a tiny slice of production traffic. In week 6, you slowly dial that up until it covers everyone. And only then, once everything is proven and stable, do you move to the final phase, flipping the switch to strict mTLS across the entire cluster.
And when your security team comes knocking and asks you to prove that this whole thing is working, you're going to be ready. You won't just tell them it's secure, you're going to show them. You'll pull up the dashboards that prove 100% of your service traffic is encrypted with mTLS. You'll explain how every single request is authenticated with strong cryptographic identities. And you'll present your stage rollout plan not as some technical detail, but as a core risk mitigation strategy that protects the business.
So we end up back where we started, but with a whole new level of understanding. We've gone from not even knowing what our services are saying to each other, to ensuring that every single one of those conversations is private and authenticated with mTLS. But that naturally leads to the next, more mature security question. Just because two services can talk securely, should they be allowed to talk at all? That question, the shift from encryption to authorization, is the next step on your service mesh journey.